last class we must have gone through the five methods. So in this class we go to the fairness criteria. So ever since we start discussing about voting methods, there is always one question: is this voting method fair? So for that, we are saying okay, let's look at four criteria, which are like we want that a voting method to satisfy this. Like we're taking a voting method and that has to satisfy these four criteria. The first criteria is that if a candidate receives all the first place votes, like there are 100 people voting and 60 people say that A should win, and it is fair to say that A has to be the winner. That's a very fair criteria. And it gets a bit complex from now on. So criteria two says that if we are like pairing each candidate, like let's say we are looking at there are four candidates in this city. So let's look at A, B, C, and D. So let's just look at A and B, and we say that A wins. You look at A and C, A wins. You look at A and D, A wins. Then it is fair to say that in this election, A has to be the winner, right? Like it is beating all the three other candidates when we are looking at the facts. So we expect our voting method to satisfy this criteria. And then we look at criteria three, which is like, so suppose there is a candidate who is declared winner of that election. So now there is another election in which all the others remain the same and X is ranked higher than in the second election. So let's say that in the first election it was like X, A, B, maybe some people said that. Some people said A, X, B, maybe 10 people. And this is election 1. In election 2, these people said the same. And the next 10 people, they also agreed that X has to be above A and B. So if X wins this election, it is fair to say that X has to win the second election because now X is more popular than the first election. So that is another criteria. And we look at one more criteria, that is criteria 4. So suppose that X is declared winner in one election. And in the next election, some candidates drop out. Like if there were 5 candidates, X, A, B, C, and D. In the next election, suppose there was X, A, and D. If X wins this election, in the next election, we expect X to win. And our voting method should satisfy that. Now we can see that, so these are the 4 criteria. That is, what is, if someone receives the majority of first place vote, he has to win. And second one is that if someone wins all the fair races, he has to win. And third one says that if someone is, like in the second election, if the winner is voted higher, then he has to win. Fourth says that if candidates drop out, the winner should still be the same. So let's look at one example where this is the voting profile. Like 5 people say that A is first, B is second, and C is third. 4 people say that B is first, C is second, and A is third. And 2 people say that C first, B second, and A is third. So we look at this and we see this satisfy all the 4 criteria. So let's look at the first criteria, which is saying that A is winning. So A got 5 first, B 4, and C 2. So the first criteria says that A has to win. And the issue here is that if I say plurality winner and B, so A is already winning. A doesn't have the majority. If you look at there are 5 plus 9% voters. For the majority, there has to be 6 votes. A has to get 6 votes. So A is not winning the plurality, and we don't need to use the first criteria here. This is a very good example for that. So we'll go to criteria 2. look at A versus B, A versus C, and B versus C. So A versus B. So in the first one, 5 people prefer A over B, and the second one, 4 people prefer B over A, and here 2 people prefer B over A. So it's 4 versus not 4, 5 versus 6. So B wins. And let's look at B versus C. So in the first one, 5 people prefer B over C. Second one, 4 people prefer B over C. And the third one, 2 people prefer C over B. So this is 5 plus 10. B has 9 votes and C has 2. So here also B wins. So we can see that B is beating both A and C. So we expect B to be winning the selection. But if you look at the plurality, A is winning because A got 5 votes. So it is actually violating the second criteria. Count C and A, but so by second criteria B has to be, so I'm skipping that. So now we look at criteria 3, which is, so here A is winning. So now suppose the people who didn't put A at the top move A to the top. So suppose this changes to, let's say, B, A and C, and this changes to C, A and B. By plurality, it doesn't make any difference because A is still winning by 5. No one can, like, we are just saying that we are bringing A to the top. And it doesn't matter if A is here or here. If it's here, it's better. Like, it will be like A, B, C. A will get more votes. It's not like A will lose votes. A will only gain votes. It is 5 here. Now, if you look at this, it will be 9. So A is getting more votes in its favor. And by plurality, A is still going to win. So we have it here. Like, column 1, we had A, B, C. We cannot change that because A is already at the top. We can move A higher in column 2 and column 3, which will give A more first place votes, but we are not going to reduce any of A's vote. So by criteria 3 is also satisfied with. Now we look at criteria 4. That is when one of the candidates drops out. Let's say that B drops out. Then we have A over C, 5 people preferring that. Yes, B is dropped out. So C over A, 4 people prefer that. C over A, 2 people prefer that. So in this selection, it's just 2 candidates. A has 5 votes, C has 6 votes, C is going to win. And let's say that B drops out. No, C drops out now. So here there is A and B. A is preferred over B. B is preferred over A by 4. B is preferred over A by 2. Again, B wins here. So when one candidate drops out in this election, A will win. And we don't want that to happen. So this method actually violates criteria 4. So in last class, you must have gone through all the 5 voting methods, and this is a summary of that. Like, you can see that the voting system doesn't satisfy criteria 1, and criteria 2, almost all of them doesn't satisfy. And you can see here criteria 4, none of them satisfy criteria 4. That is a very difficult criteria to satisfy. Like, I'm usually used to manipulations. Like, if you look at the previous elections, you can see the big parties trying to make the opposite candidates drop off. Like, if there is A, B, C, and D, if A thinks that his vote is going to C, like they have a similar ideologies, then A will want C to drop off, and they will get all the votes C will get off. This usually leads to manipulation, and in 1950, there was a guy called Kenneth Arrow. He proved that no voting system can satisfy all these criteria. So he theoretically proved that there is no perfect voting system. So whatever we do, any voting system we take is going to violate one of these criteria. So now we know that there is no voting system which is perfect. We are trying to see which is the most fair one. So people have come up with many new things, and one such system is called approval voting. So you must have heard that during the selection season, saying that this candidate has this much approval rating. So what is an approval rating? So you go and ask people like, do you approve of this candidate? It's going to be a simple yes or no. So you can maybe approve two candidates, and they will not vote. So now we don't have to choose one candidate. We can say that okay, we are indifferent between A and B. So they count both of them. So approval voting asks voters to specify whether they approve or disapprove of each candidate. Voters may approve as many candidates as they want. And the one with most approval votes wins. So we will look at one example. So there is a race for an governor, and there is three candidates, A, B, and C. 26 people want A as their first choice. And A will also approve B. 25 people want A as their first choice, and they don't want B or C. 15 want B as their first choice, and they don't want A or C. And 18 want C as their first choice, but they would also approve B. And 16 want C as their first choice. So if you add all these numbers, you will see that it's going to be 100. So it is 51 plus 15 is 66 plus 34, that is 100. So all the 100 people, like all the people are counted here. So now if you look at two methods, one is approval voting and one by plurality. Let's see who wins. So let's look at approval voting. We look at how many people who prefer A. So people prefer A. We also know B, but we don't care about that now. So these people want A. So A will have 26 plus 25. These people don't want A, so we don't count them. These people don't say about A, so that means they don't want A. These also don't want A. So A will have 51% approval vote. So now we look at B. So these people prefer B, so that is 26. They don't want B, they want B. So that is 26 plus 15. They will also approve B, that is 18. And they don't want B. So we can add them and it will be 20%. Similarly, we can add C, use C that is equal to 34%. So who's going to win this one? If it's by approval voting. Yeah, so B will win the selection because they have most approval rating. Now, if you look at the plurality, let's say A 26 wants A as their first choice. 25 again wants A as their first choice. Even that is 51. It's already A won. 15 want B as their first choice. 18 wants C, and here also 18, 16 wants C. So when you summarize them, you will see that 51 want A as their first choice, 15 B, and 34 C. So who is going to win this? It is by plurality. So A is going to win this. So majority of voters want A as their first choice for governor, but they will find that B is also acceptable. So if you look at the approval voting, we are actually trying to find someone who is more accepted than people want there as the first choice. So this actually violates criteria 1 in our with the previous criteria because A received more than the majority. But A is not winning this election, not this one. In the approval voting, they are not winning the election. So even approval voting actually violates some criteria, and we still have this issue like we cannot find a perfect voting method. Since we have a lot of there is one example which we can try it now. So we'll use the point system. So let's say that uh, C is preferred to A is preferred to B, and let's say that 5 people ask this B over C over A. 5 people prefer that. A over B over C. 3 people prefer that. Can you go through all the criteria and say like what violates like the system violates which one? Like you have 4 criteria. Can you go through that? Point system. People who are first will get 3 points, and two, second will get 1 point, and third will get 1. So the first criteria is that whoever gets majority of the votes should win this election. So there are 12 voters. 5 people prefer A, so that means there is no majority. 4 people prefer B, and 3 people prefer A. So there is no clear majority, so the first criteria is not valid here. That says that if someone gets a majority, then that person should win. So since that if statement is not satisfied, we don't need that. It's not valid. So what is the second thing? So if someone is preferred over any other candidate, that candidate should be the winner. So yes, first find who's the actual winner. So C will get 15 points, that is 3 times 5, plus 2 times 4, which is 8, plus 1 times 3, which is 26. We will get 12 plus he gets 4 here, 5 here, gets 6 here. So we will get 23. And A gets 10 points here, 4 points here, and 9 points. So C is our winner. So we because we know that C is the winner. So now we look at the pairwise races. So let's look at A versus C. C gets 5 plus 4, which is 9, and so it's A versus 9, and C wins. We look at B versus C. So C gets 5 here, and B is preferred in the other 2 cases. So it's 7 versus 5. B wins. Now A versus B. So B gets A over B for 5 people plus 3 here. So it's 8 versus 4. So you can say that no one is winning the pairwise race. So that means the criterion 2 is also not valid here. You don't have to look at that. So all of these are if statements. Like if someone wins all the pairwise races, then he has to win the final. So since that is not satisfied here, we can say that the second one is also not valid. Now let's look at criteria 3, which is someone gets voted higher in the second election. So let's say that A is voted higher in the second election. I'm changing this profile to this, and maybe A here. Yes. Now when you count the votes, we'll just count A. A is going to get 5. A is going to get 50 plus 2 times 8, which is 2 times 4, which is 8, plus 5 times 3, which is 3 times 3, which is 9. It's going to be 32. So A is clearly going to win this race because C and B are like much below that. So we change A and voted it to the top. We shouldn't be changing A, we should be changing C. So we can't change it. We have to bring the figure to it. So C wins, so we will just keep AB as it is. We'll bring C to the top. And here also we will bring C. So we will get more votes. So obviously C is going to, we don't have to count it. We are just see if it in this count. C will get 50 plus here again 3 times 4, which is 12, plus 2 times 3, which is 6. C is going to get 80 plus 50, which is 33 votes. The C is going to get more votes now. So that means C is going to get. So you can say that this satisfies criteria 2. Now the criteria 4 is when someone drops out. Let's say A drops out. So we don't want this. So here we are back to zero majority because there's only 2 candidates. I will look for A 0 and 7 will look for B over C. So B is going to win, and this is a violation of criteria 4. So we can say that the first one is not valid, second one is not valid, third fails, and fourth fails, which is kind of what we have here, like scoring system. First one is not valid, but we can always find an example where it is validated. Our example is not validated, but we can always find something. The criteria 3 is always satisfied, and criteria 4 is never satisfied. So there's always theoretical ways to show this. So now let's go to voting power. So we'll use one example to show this. Like so, in a company, like shareholders are given the voting proportion according to number of shares they have. It's not like all of them are given equal voting power. Like if someone wants 50% of the company and someone wants only 30%, the person who is wanting 50% should get more voting power. So there's an example, I'll show an example. So a company has 10,000 shares and shareholder A has like 2,650. That's like 26.5 shares. B has 25.5, C has 25, and D has 23. So if you give them equal voting power, that's not fair. Like he's wanting more, so he should be getting more voting power. So whenever they vote, if shareholder A says something, he's going to get 26.5 weightage in that vote. So if shareholder A and B agrees on something, we are going to add 26.5 plus 23. So that is what we call voting power. So we are dividing it according to the number of shares they have. And some people can make correlations, that is, before the voting, they can talk to other people and say that we are going to vote in the same way. So then we will see that the individual voters' power is affected. Like if 2 people come together and say that we are going to vote in the same way, then voting power is going to increase. Like if A and B decide that we are voting in the same way, more than the majority, and they can easily pass what they have. So before going to the voting, they team up, they know that they are going to win, no matter what the other people do. So this leads to manipulation. Manipulations they arise very common in this kind of things. We cannot avoid them, and in most of the cases they are legal. So we'll look at an example. So they say key vote about buying out another company, and D misses the vote. Misses the vote. The key didn't show up. So what does it matter? Do you think it will matter if D misses the voting? It really doesn't, because D has only 23% of the share. So if let's look at, like, if shareholder says yes, shareholder B says yes, that's like more than 50%. So that is going to pass even if D doesn't show up. And suppose shareholder say A says yes and C says yes, again that's more than 50%. So D doesn't really have any power here. So which any two of the largest shareholders can form a majority if they vote together. You can see that if A and B vote together is 52, and if it will pass. A and C if they vote together is 51.5, and B and C if they vote together is 50.5. In fact, D doesn't have any power here. If suppose like D votes yes on something, even if he shows up and he says yes, and if only one of them agrees to him, like let's say only A agrees to him, what will happen? So it's 23 plus 26.5 is only 49.5. That is 49. If B and C votes against them, that is going to pass. So, and this is the highest value. The best chance for D is when someone will be highest, which is A voting with him, and even then it is not enough. So D needs at least two other people to vote with him. So if D had A and B for company, then it will pass. But do you really need D here? Even if D was not there, it will pass. So D here doesn't have any power at all. So his vote is kind of useless. So let me see if there's another example. You can see this happens in the elections, like representative elections. Like not all states have even the same weightage. So some states will have 8 votes, some will have 15 big states. All of them depends on the population. Like if there's a big state like Texas or California, they have more population, so they will have more vote share. Not vote share, they will have more electoral votes. And the small states, maybe like a Rhode Island or something, will have very low electoral votes. It's not about fairness, it's about how many people they have. And you can see that sometimes some states votes doesn't matter, because if two big states have enough electoral votes, then they will win. So that's why we have this issue of the swing states. And the party is concentrating more on the swing states. And I went through the slides so quickly. This is the end of the slides. Is there any questions on this chapter? Like I can go through it again. Like the fairness criteria and the approval things. election was decided by plurality, who is going to win this election? You can answer. The one who gets most votes. Yeah.
Would it be B?
Yeah. So B wins by plurality. And if it's by a single runoff method, who is going to win that? So the single runoff method is going to be with B and A. So you look at B and A. What is the result of B? And the remaining 39 plus 18, which is 57. So 57 prefer A over G. So A is going to win this. So if by single runoff, A is going to win this. So now the next question is criteria one satisfied? Since they don't have half the total votes, that's like 50. It's not valid here. Yeah, suppose B is declared the winner. Is criteria 2 satisfied? So criteria 2 says that you look at the pairwise spaces, and if B wins against all of them, B has to be the winner. So we look at pairwise spaces, and B versus A is going to be 43, and all the others are against 43 versus B doesn't win, so we look at A versus C. So 43 plus 39 prefer A, so that is 82 people prefer A. Or A actually beats C and B in pairwise spaces, so A should be the winner, but A is not the winner. So criteria 2 is not satisfied if B is the winner. If A was declared the winner, we can say that criteria 2 is satisfied, but then it is by some other way. Now, we suppose C drops out. Will criteria 4 be satisfied? So criteria 4 says that if someone drops out, it's very interesting. So suppose B was declared winner and C dropped out. Will criteria 4 be satisfied? So, C drops out, A is going to be the winner, and criteria 4 will not be satisfied. But in the original one, if we had declared A the winner and C drops out, A is still going to be the winner, and criteria 4 will be satisfied. So it's very logical thing. Like we have to first declare the winner, then only we can say whether the criteria is satisfied or not. So all these statements are if states. If this happens, then only we can say. In the chapter. So we cover 12.3 next time and like on Thursday, and I won't be the one teaching. Dr. Darius won't be back on Thursday also. One of your DL will be teaching. So maybe we can start the class with. Like I know it's a bit early, but he just told me to cover 12B.
Okay.
I covered